Going to continue building up with our concept of doing these things in calculus towards sketching a cubic function. Now remember, the cubic function looks like that, and I also said the type of function that the cubic is. What is this? What type of function is it? It is part of a set of functions. It's part of a family. What family is that? The family of polynomials, right? And remember, this is a polynomial of degree what? Degree what? Degree 3, right? Okay, very good. Okay, so it's a polynomial of degree 3. And the number of turning points that a polynomial of degree 3 has? Is it 3? 2, right? Because the number of turning points is always? It's n minus 1. If the degree is n, then the number of turning points is n minus 1. Okay, so remember I said to sketch any graph. Now one of the WhatsApp subscribers said I need to speak a little bit slower on our videos, so let's speak a little bit slower. To sketch any graph, as you know, we need what? X-intercepts, we need y-intercepts, and we need if we're dealing with polynomial functions, we need what? We need what? What are these points over here? We need the turning points, right? So we've already seen how to find the x-intercept using synthetic division if it's something of degree 3, and we've seen how to find the y-intercept by simply making x 0, and now we are going to build up to finding what? The turning points, right? So before we go into that, I want to take you back and I want to ask you, how do you find the turning point of a parabola? And I'm going to give you some parabolas, right? So remember, the standard form of a parabola is what? Ax squared plus c, right? Now, if I gave you this parabola, y equals, I'm going to put it in that standard form, x minus 3 all squared, which means it's going to be x squared plus or minus 6x plus 9, with the corresponding a, b, and c values. What is a's value here? Right, b and c? Positive 9, right? Okay. Now, I want you to use this form and find the coordinates of the turning point for me. Can any of you do that? What do you need to do? What's the first step? So you use the turning point formula, which is what? Right? X coordinate is minus b over 2a, and then you take that and you substitute it into the x values, very good, which is what? F of minus b over 2a. So that's your exercise very quickly. You do that, and you can pause here and then I will check it again. Okay, so let's use sky blue and see if we substitute those values in. If I put minus b there, if I put minus b, that's minus 6 over 2 multiplied by 1, right? And you can tell me that that is equivalent to what? That's equivalent to 3. And then when you take that 3 and you substitute it in here, what happens? You get a final answer of 0. So can you tell me what the turning point is for this function? The turning point is 3 on the x and 0 on the y. Okay, let's go and verify that and see if that's what this function looks like using our graphing calculator. So the function was x squared, right, minus 6x plus 9. Okay, and there I can see the turning point. The turning point occurs at what? At what? 3 and 0. Very good. Let's do one more just to see if you know how to do it. Okay, I'm going to give you this function. Y equals x squared minus 3x minus 4. Again, using the turning point formula, which is simply to say that the x coordinate is minus b over 2a and the y coordinate is f of minus b over 2a. Okay. Once we are done here, we're going to start reflecting on these steps and then see how we can extend this strategy or this set of steps towards the cubic graph. Okay, so when we substitute in minus b over 2a, we can clearly see that my a value here is equal to 1, my b value is equal to 3, and my c value, negative 4, right? And when you substitute that in, what do we get as a result? We get 3 over 2 and the result of that is negative 6.25, which is the same as negative 25 over 4. Okay, let's see if that is correct. I'm going to put that function in Desmos. Okay, what do I have over there? X squared minus 3x minus 4. And there's my turning point, which occurs at positive 1.5 and negative 6.25. Now, as you're aware, positive 1.5 is the same as 3 over 2. Okay, very good. Okay, so what you've now seen is actually an application. This whole thing was an application, right, of a calculus-based result. In other words, what we did now is we used a shortcut that really came from calculus. Okay, and that's what we're going to see next. Okay, where did this result really come from? Okay, are we good? Okay.